Hey guys, welcome to Paul's Maths Labs, and today we're going to be looking at trigonometry, and we're going to be looking at finding missing sides. Okay, so first thing first, what we're going to do. So let's look at this question first. So first thing that I want us to look at is what sides have we got, or what sides do we have, or are we looking for? Now we are looking for this. We have or are looking for this side and this side. So we have this side and we are looking for this side. Okay. Now, what are these sides? Are they opposite? Are they hypotenuse? Are they adjacent? What are they? So we know that this side here, which is the longest side, we know it is the hypotenuse. Okay. So x is the hypotenuse, and we know this side is opposite of the angle given. The angle given is 48. Opposite of that, the side, which is the opposite, is 9 centimeters. So we know that this is the opposite, and that is the hypotenuse. Okay, lovely, lovely, lovely. So now we need to look at which one of our trigonometric ratios have the opposite and the hypotenuse. Is it tan? Tan has opposite and adjacent, so no. Is it the cos theta? No, it has adjacent and opposite. No. Sine theta, yes, sine theta has opposite and hypotenuse, so that's good. So we are going to say sine, and we're not going to put theta anymore because we already have a value for theta. Our value for theta is 48. So sine 48, and I like to put that in brackets, sine 48 is equal to the opposite, which is 9, over the hypotenuse, which is x. Lovely. Now, in order to find out what our value for x is, we need to do a little bit of rearranging. Okay, so we're going to rearrange this a little bit so that we have x on the left hand side by itself. Okay, so first thing we're going to do, we're going to multiply both sides by x. So if we multiply both sides by x, we're going to have x sine 48 is equal to 9. Okay, now the next thing that we're going to do is we're going to say, oh, well, I only want x on this side, so I need to get rid of the sine 48. In order for me to get rid of the sine 48, I need to divide both sides by sine 48. Okay, so we're going to have x is equal to 9 divided by sine 48. Okay, that is meant to be a 48. So now we're going to plug in the calculator, 9 divided by sine 48, and see what we get. So 9 divided by sine 48 is going to give us 12.11 to 2 decimal places. So that's going to give us 12.11 to 2 decimal places. And remember, we need to put in the correct units, which is centimeters. Okay, lovely. So that's one question down. Let's look at the next one here. So here we have been given this side, and we are looking for this side. Okay, so this side is what? What is this side? The opposite, adjacent, or the hypotenuse? Well, we know that the longest side is opposite of the right angle, which is x. We know that this is the hypotenuse. And we know that the side opposite of the angle given is the opposite. So we know that this is the opposite. Then obviously this must therefore be the adjacent. Okay, so we've got a problem that has the adjacent and the hypotenuse. So which trigonometric ratio has the adjacent and the hypotenuse? Adjacent and the hypotenuse, well, it's cos theta. Okay, so we're going to write down, and we're not going to put theta because we know we have our value for theta. Our value for theta is 42. So cos 42 is equal to the adjacent over the hypotenuse. So it's equal to 10 over x. Okay. Again, we need to do a little bit of rearranging. So we're going to basically have x cos 42 is equal to 10. And we do further rearranging to find out what x is by itself. And we have x is equal to 10 divided by cos 42. Okay? So 10 divided by cos 42, what do we get? 10 divided by cos 42 is going to give us 13.45. And if we're rounding it to 2 decimal places, it will be 13.46 centimeters. Okay, another one done. Let's look at this question here. So we are looking for this side and we have got this side. So let's see. So we've got the hypotenuse is here. The opposite is here because it's opposite of the angle given. That's the angle given, opposite of that. That's side opposite. And therefore this must be the adjacent. Okay, so we've got the opposites and we've got the adjacent. So that is tan and tan theta, and our theta is 70 degrees. So tan of 70 is equal to 18 over x. Okay, doing a little bit of rearranging, we're going to get x tan 70 is equal to 18. And doing further rearranging to get x on its own, we're going to get x is equal to 18 over tan 70. Okay, and that should give us 18 divided by tan 70 is going to give us 6.55. 6.55, and don't forget centimeters. Lovely. Okay, let's go down to this one. So here we're looking for this side and we've been given this side. So we have the hypotenuse here. This is the opposite and this must be the adjacent. Okay, so we've got the adjacent and we've got the opposites. So adjacent and opposite is tan again. So we've got tan 45 is equal to 7 opposite over the adjacent over x. Okay, rearranging it, we're going to get x tan 45 is equal to 7, and rearranging that further to get what x is equal to 7 divided by tan 45. Okay, and that is going to give us 7 divided by tan 45 is going to give us 7. Okay, and remember centimeters. So that triangle is actually a what do you call it? It is actually a isosceles triangle. Okay, and you could have told that, you could have known that, because you know that's 90, that's going to be 45, and if that's 45, that's going to have to be equal to 45 as well, because angles in triangle have to add up to 180 degrees. Okay, so guys, that is really it for finding missing angles in right angle triangles using trigonometry. Okay, so the next video that we're going to be looking at is finding missing angles this time. Okay, so what we've done today was finding missing sides, and then what we're going to do next time is finding missing angles. Okay, and you're going to see that's a little bit harder, shall I say. Okay, so thank you guys very much for tuning to Pause Maths Labs, and I'll see you guys later.